So our goal here is to quickly go through how to find a line of best fit, and in particular the slope of that line, um, using a set of data. So here's a set of data showing the diameter of a circle compared to its circumference. And we're after pi, so it's the circumference is equal to pi times the diameter. So if we look at y equals mx, y would be the circumference, the m or the slope would be pi, which is what we're after, and the diameter would be the equivalent of the x. These here are, we've already calculated pi by dividing the circumference by the diameter. And we could average these, but as we've talked about hopefully at this point in class, the way physicists usually do it is they use these x and y pairs. So every one of these is an x and a y. In fact, I'll write this, we treat the diameter like the x, quote, x. And in this case, we're going to treat the circumference like a y. And don't mind the fact that the data is changing. In fact, that's just the way I set it up. We're going to do this. We're going to control copy, and we're going to add a sheet. We're going to say base values. There we go. I'm going to say formatting. There we go. These shouldn't change like the other ones were doing. Okay, so the process to find that line of best fit is you have to make a scatter plot. So we highlight the two columns, the x column and the y. I like to try to rearrange it if I can and put them one on the x should always be on the left, the y should be on the right. So highlight the two columns of numbers. Then go to insert. So jot that down, insert. And then right in the center of the bar at the top there where it says charts, you can see a little scatter plot. Drop that down, just going to do a regular old scatter plot. I don't even know what the other ones are. Boom. And then here's your data, lined up, ready to go. So far, piece of cake. If we were really going to turn this in for a lab, we'd go in and we'd put axes and stuff like that. But for now, I'm focusing on how do we get that line of best fit and how do we find the slope from that line. So we go to our graph, we right-click, and we pick the option that says Add Trend Line. This little thing over here pops up. It's already set to a linear line. You could do a linear line. Well, it's kind of redundant. To a linear fit. You could do others, but this data is definitely a line. And what we're going to do in future classes, actually the next class probably, at least the year that I'm making this, we're going to learn how we can make even things that don't look linear, that aren't linear, kind of look like lines. Not kind of, definitely look like lines. So all we need to check are two boxes. We go down to the bottom, the last two. We want to select display the equation on the chart, and just to make us feel better about the world, display the r squared value on the chart. Boom. And they'll show up right here. You can close that out in the upper right here. Boom. So zooming in, my eyes need to zoom in, not yours. There we go. So here's our line of best fit, and it's in the form of y equals m, which is the 3.2686 x, minus b, or in this case plus b. This is the intercept. It's damn near zero, so it really is, in this case, we definitely can ignore it. What we want is our experimental value for pi here is this 3.27. Since I gave you two decimal places here, we'll just go with that, 3.27. Maybe I'm, significant figures, maybe I'm supposed to say 3.3. I don't know. It doesn't matter to me. I guess, yeah, 3.27 would be right. I never worry about that stuff. We could, if we wanted, compare that to, so you can find the average, you can equals average, parenthesis, you could find the average of all these and see how it compares. So I'm not worried about which one's better or closer or whatever. This is the technique that you're going to have to be able to do to fill out a lab, is this finding the line of best fit business. And it's much easier on Excel than it is doing it by hand. You don't have to worry about the scaling, the picking the points, and all that. It just does it right for you. So that's it. That's all you got to do. So practice that a couple times, please, so you know what you're doing.